Hello everyone, this is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. Welcome to today's lecture. In this lecture, we'll be discussing about some definitions and terminology that we use in number system, that is a third module of our analog and digital electronics course. We all have studied the basic concepts of number systems and the various codes, weighted codes, non-weighted codes, error detection and correction codes, and what is a Boolean algebra, and all we have seen in the third module. So we'll have some discussion on the definitions and terminology related to the number systems. So first one is define binary number. So what is a binary number? How can we define a binary number? The binary number system is a number system that represents numeric values using only two unique digits, 0 and 1. The most computing devices use binary numbering system to represent electronic circuit, voltage, state, that is on or off, and the base of this number system is 2. So the binary number system is having a base or radix of 2, and it is having only two symbols, those are 0 and 1. So every information will be represented in the form of zeros and ones. So that is binary number system. And coming to the decimal number system. So every number system will have its own base or radix. So whereas the number of symbols in the base or else any number system is equals to the radix. So the number system, that is a decimal number system, is a system in which each number is expressed in base 10 using one of the first 9 integers or 0 in each place and letting each place value by a power of 2. So here the base or radix of decimal number system is 10 and it allows 10 symbols. So where the symbols are 0 to 9, that means these 0 to 9 are the symbols of a decimal number system, and each digit in a decimal number will have its own positional weight that is expressed in terms of powers of 10. For example, if we have a decimal number 112, so the positional weights, actually it is a 3-digit number, so the positions of this 3-digit number are given by 0, 1, 2. And the positional weight, each digit will have its own positional weight, which is expressed as power of 10. So the weight of this decimal number is 10 power 2, that is hundreds position, and this is 10 to the power of 1, and this is 10 to the power of 0. That means the place of this one is ones place, tens place, and hundreds place. Like that, each digit will have its own positional weight, which is expressed as a powers of 10. So a decimal number system is a system in which each number is expressed in the base 10 and which can be represented by using any one of the first 9 integers, those are 0 to 9. And in this decimal number, each digit will have its own positional weight, which is expressed as power of 10. Now coming to the octal number system. So as the name itself indicating, octal number system. What is an octal number system? So octal number system is a number system in whose radix is equals to 8, and the symbols included in the octal number system are 0 to 7. So total the number of symbols that are included in octal number system is equals to 8, including 0 and 7. So the total symbols of an octal number system are 0 to 7. That means each number in octal number can be represented by using any one of these 8 digits starting from 0 to 7. And octal number system, each digit will have its own weight, positional weight, which is expressed as power of 8, So for example, if we consider an octal number, so which includes any of the symbols from 0 to 7, so 765 is an octal number, and the positional weights of each digit in the octal number is represented as power of 8. So the digit 5's positional weight is 8 power 0, and 6 positional weight is 8 power 1, and 7 positional weight is 8 power 2. So this is about the octal number system. So that is how you can write down the octal number. For example, if you have a number like 7865, so is it considered to be an octal number? No, because this is not a valid symbol of octal number system. This is not valid symbol of octal number system. So this is not an octal number. So that is how you have to remember. So octal number system is a system whose radix is equal to 8 and which includes 8 symbols starting from 0 to 7. So, and each digit in the octal number will have its own positional weight, which is expressed as power of 8. This is how you can define the octal number. And coming to the next one, hexadecimal number. So hexa, as the name itself indicating, hexadecimal number system is a number system in whose radix is equals to 16 or else base is equals to 16. This indicates that this hexadecimal number system includes 6 symbols. Those are 10 symbols, that is 0 to 9, and whereas 10 to 15 in hexadecimal can be represented with capital letters A to F. A is nothing but 10 and F is nothing but 15. So that means 10 to 15 are represented in hexadecimal as A to F and 0 to 9 are normal decimal numbers. So the hexadecimal number system is a system whose radix is 16 and it includes 16 symbols. Those are 0 to 9 and 10 to 15 are represented as capital A to capital F. So whatever the number that includes these symbols 0 to 9 and A to F will come under or else will be considered as an hexadecimal number. So here and as a base of this hexadecimal number system is 16. So each digit in the hexadecimal number will have its positional weight as powers of 16. For example, A, B, C. So this is my hexadecimal number because A, B, C are the symbols of hexadecimal number system and whose positional weight, C's positional weight is 16 power 0 and B's positional weight is 16 power 1 and A's positional weight is 16 power 2. So that is like that each digit in the hexadecimal number will have its own positional weight which is in the power of 16. So now coming to the complement, define one's complement. How can we define one's complement? The one's complement of a binary number is defined as a value obtained by inverting all the bits in the binary representation of the number. Inverting in the sense by simply changing the ones to zeros and zeros to ones. So that means the ones complement of a binary number is defined or obtained simply by changing the binary ones to zeros and zeros to ones represented in the binary form. So for example, we have a binary number, so 10110, whose ones complement can be obtained by changing ones to zeros and zeros to 1. So this 1 is 0, change it to 0, 0 change it to 1 and 0, 0, 1. So this is the ones complement for the given binary number. Now coming to the two's complement, how can we define a two's complement? The two's complement of a binary number is obtained by adding 1 to the ones complement of signed binary number. So the two's complement of positive number gives a negative number. Similarly, two's complement of a negative number gives the positive number. Complement is nothing but changing the polarity of the number. That means negative to positive and positive will be changed to negative. Even one's complement means what? It is changing the positive number into negative number and vice versa. So the two's complement. So there is a slight difference. It also gets the negative number for the given positive number. But the difference here is we have to add 1 to the ones complement of the given binary number so that the two's complement can be obtained. So here we have ones complement for this one. So the two's complement can be obtained by simply adding 1 to the LSB of ones complement of the number. So 1 plus 1, 0 with a carry 1. So 1, 0, 1, 0. So this is the two's complement for the given binary number, this one. Okay, so like that you can obtain the two's complement. Now coming to the binary coded decimal. What is binary coded decimal? So here, binary coded decimal is a system of writing numerals that assigns a 4-digit binary code to each digit 0 through 9 in decimal numeral. So that means BCD stands for binary coded decimal. That means each decimal digit is coded into binary. So how many binary numbers how many decimal numbers we have? 0 to 9. So in order to represent this 10 symbols, we need to have 4-bit binary equivalent. So that means the binary coded decimal is a system of writing numerals that assigns a 4-digit binary code to each decimal digit 0 through 9 in a decimal numeral. The 4-bit BCD code for any particular single base 10 digit is its representation in binary notation. So that means you all know that 0 can be represented in binary as 000 with 4-bit equivalent. 1 can be represented as 001. 2 is represented as 0010. 3 is 0011 and so on. 9 is nothing but 1001. So each decimal digit 0 to 9 can be replaced with its 4-bit binary code so that the BCD code can be obtained. So this is binary coded decimal. Means what? We are just coding the decimal digits 0 through 9 into binary using this BCD code. Now coming to the unit distance code. Define unit distance code. What do you mean by unit distance code? So a unit distance code is said to be an unweighted code or else non-weighted code that changes at only 1-bit position when going from one number to the next number in a consecutive sequence of numbers. So unit distance number means if 2 consecutive numbers are differed by only 1-bit positions, then such type of codes are said to be unit distance code. So this is, and use of one of many unit distance code can minimize error at symbol transition points when converting analog quantities into digital quantities. So these kind of unit distance codes are mainly used in order to convert in the applications where we use analog to digital converters, or else whenever we are changing the analog quantities into digital quantities, we will be using this unit distance codes. So unit distance codes are the binary codes in which 2 consecutive codes will be differed by only one bit position. Such codes are said to be unit distance code, and the example for unit distance code is gray code, in which each successive code or else consecutive code is differed by 2 consecutive codes are differed by only 1-bit position. So that is why they are said to be unit distance code. For example, we have a gray code, 2-bit gray code. What is a 2-bit gray code? 00011110. Right? This is a gray code for a 2-bit gray code here. So A1, A0. So if you observe these two, how many bit positions these are differed by? Only 1-bit position. And these two are also differed by only 1-bit position. And these two are also differed by only 1-bit position. So that is why these are said to be, this is said to be unit distance code. Unit distance code. So that is a definition of unit distance code. Now coming to the parity bit. What do you mean by parity bit? Define parity bit. So parity bit is an extra bit added to the message bit such that the number of ones present in the code may become either even or odd. So it is easy to include one parity bit either to the left of MSB or to the right of LSB of original bit stream. There are again 2 types of parity codes, namely even parity and odd parity, based on the type of parity being chosen. So in short, we can define the parity bit as it is an extra bit added or else appended to the message or else data bits either to the left of MSB or to the right of LSB of original bit stream, such that the number of ones in the given message or data becomes either even or odd. And based on the number of ones, whether it is even or odd, we have 2 types of parity bits. Those are even parity and odd parity. Now let us discuss what are the error detection codes. So error detection codes are used to detect the error present in the received data. So in communication, transmitter will send the data through the channel and the receiver will receive the data. So while the transmission, there may be some errors. So in order to detect that errors, we will be using some error detection and correction codes. So these codes contain some bits which are included or appended to the original bit stream, and these codes detect the error if it is occurred during the transmission of the original bit stream. So here error detection and correction codes are nothing but the codes which are used to detect and correct the errors present in the received data, and these codes contain extra bits which are added along with the original bit stream, and such that they are able to detect the errors. So while the message is being transmitted, due to some noise, there may be some error. In order to detect some errors, we will be adding some or else appending some extra bits. So based on this, we have two types of codes. Those are parity code and Hamming code. So that is about error detection and correction codes. Now, first of all, what is error correction? Error correction means if error correction codes are used to correct the errors present in the bit stream, so that we will get the original data. Error correction codes also use the similar strategy for error detection codes. And the best example of error correction code is Hamming code. So this means error correcting codes are the codes that are used to correct the error present in the received data. So here, whatever the strategy that has been followed in the error detection, the same strategy will be applied even in the correction also. De Morgan's theorem. What is De Morgan's theorem? So the complement of a product is equals to the sum of the products and vice versa. So here the De Morgan theorem says that A plus B whole complement is equals to A complement dot B complement. So that means I can define the De Morgan's theorem as the complement of sum of two variables is equals to the ANDing of two complemented variables, that is A plus B whole complement is equals to A complement dot B complement. Similarly, A dot B, that is sum or product of the complement of sum or product is equals to the product of or sum of the complements of the variables. So this one becomes A bar plus B bar. So this is the De Morgan's theorem. By applying the De Morgan's theorem, we can get the complement of a given Boolean function. Now coming to the Boolean algebra. Define Boolean algebra. What is Boolean algebra? Boolean algebra is also known as switching algebra. It is a system of mathematical logic to perform different mathematical operations in binary systems. So it is a mathematical logic that can help us to perform different mathematical operations on binary systems, and these are having only two elements, 1 and 0, by which all the mathematical operations are to be performed. As this, why we are calling this as Boolean algebra? Because it deals with the Boolean variables. What do you mean by Boolean variables? The variable which can accept only two values, that is binary 1 and 0, it is said to be Boolean variable. So the algebra which can be applied on Boolean variables is known as Boolean algebra, or else Boolean algebra is also known as mathematical principles. It is a collection of mathematical principles that can be operating on binary data. So there are three basic binary operations. What are the three basic binary operations? And, or, and not, by which all simple as well as complex binary mathematical expressions are to be done. So there are some rules and postulates in Boolean algebra by which those mathematical operations are done. So Boolean algebra consists of some set of rules and postulates by which the mathematical expressions are going to be simplified. Why to simplify the Boolean expression? In order to reduce the number of gates that are required to implement it, and also in order to reduce the cost and complexity of the circuit. So next up, defines the SOP form. What is SOP? SOP is nothing but sum of products form. So canonical sum of products form means canonical sum of SOP. In this form, Each product term contains all the variables or literals of the given Boolean function. So these product terms are nothing but the minterms. Hence, the canonical SOP is also called as sum of minterms form. So what does it mean? The sum of products form is nothing but representing a Boolean function as a product as the sum of various product terms. So product terms are also called as minterms. When we can call the product terms as minterms? If it includes all the variables either in true form or complemented form. So that is canonical SOP form. Okay. Now coming to the POS form. What is POS? How can we define POS? POS is nothing but product of sums. So the canonical POS form means canonical product of sums form. What does it mean? Canonical means if all the terms includes all the variables, whether in its true form or complemented form, it is said to be canonical form. Canonical product of sums form. In this, each term contains all the variables. So these sum terms are nothing but the max terms. Hence, the canonical POS form is also called as product of max terms form. Now coming to the binary. What is binary? Binary is a number system that uses only two digits, 0 and 1. The computers that operate in a binary meaning they store the data and perform the calculations using only binary ones and zeros. A single binary digit can only represent two values, two Boolean values. What are those two Boolean values? That is logic true or else logic 1 and logic false and hence logic 0. So that is about binary. Define number system. So a number system is a collection of various symbols which are called digits. Different types of number systems we have. Okay. So a number system is a collection of various symbols which are called digits. Okay. So that is nothing but a number system where we have various types of number system as we have seen in the first slide, like a decimal number system, hexadecimal number system, octal number system and so on. Right. So now coming to the gray code. What do you mean by gray code? A gray code is an encoding of numbers so that the adjacent numbers have a single digit differing by 1. So the term gray code is often used to a reflected code. In more specifically, still the binary reflected gray code. So that means even the gray code is also called as unit distance code, and another name for gray code is reflected code. Okay. So why? Because the code is just the last half, the last half of the binary code, gray code, or mirror image to the first half of the gray code. So that is why we can also call this as reflected code. So this is about gray code. Define XS3 code. So the XS3 code is also called as XS3, is a non-weighted code and is a self-complementary binary coded decimal code, and a number system, it is a self-complementing code. So the XS3 code is also called a self-complementing code, and which can be obtained simply by adding 3 to the binary code. 3 to the binary code. So you can obtain the XS3 code for any number by simply adding 3 to each digit in the given binary representation. Now let us see what is meant by self-complementing code. Self-complementing codes are XS3 code, 84T1 and 2421. Such codes have the property that the ninth complement of a decimal number is obtained directly by changing ones to zeros and zeros to ones. So the ninth complement of a decimal number is obtained directly by changing ones to zeros and zeros to 1. So this is such kind of that are said to be self-complementing codes. Okay, simply by changing ones to zeros and zeros to 1, if you get the other form of code, then it is said to be self-complementing code. Now define codes. So if the coding, in the coding, when the numbers or letters are represented by specific group of symbols, it is said to be that number of letters is being encoded. The group of symbols is called as code. The digital data is represented, stored and transmitted as a group of bits. So this group of bits is also called as binary code. So that means, in short, we can say that the grouping of binary data is called as codes. Okay. So the groups of binary data is known as binary code. Now coming to the Hamming code, how can we define the Hamming code? So Hamming code is useful for the error detection as well as the correction present in the received data. So this code uses multiple parity bits and have to be placed these parity bits in the positions of power of 2. So we in Hamming codes we will be adding or else appending number of parity bits or else extra bits. Where should we add this? All these parity bits should be added in the positions of powers of 2. So the minimum value of k for which the following relation is valid, nothing but the required number of parity bits. So that means here the parity bits must be satisfied. What is the condition that is to be satisfied? 2 power k greater than or equals to m plus k plus 1, where m is the number of data bits, m is the number of data bits and k is the number of parity bits to be added, number of parity bits to be added. So this is the condition that is to be satisfied in order to decide how many extra bits are going to be appended to the received message. Now duality theorem. So duality theorem of Boolean algebra is not similar to the De Morgan's theorem. What is this duality theorem says? So duality theorem states that the dual of a Boolean expression is obtained by simply changing the logical AND operator to logical OR and vice versa. Even we are changing the logical 1 to logic 0, but no variable is getting complemented. Whereas in De Morgan's law, even though the operations are changed from AND to OR and OR to AND, we are also changing the we are also changing the variables, that is complementing the variables in case of De Morgan's law, whereas in this duality only the operators are changed from AND to OR and OR to AND, but no variable is getting complemented, and also the ones are changed to zeros and zeros are changed to ones. So the dual of a Boolean function can be obtained simply by changing logical AND to logical OR, logical OR to logical AND, comma, the numbers or the variables are not complemented, but the ones logic 1 is changed to logic 0 and logic 0 is changed to logic 1. Now coming to the 8421 code. So what is 8421? What this 8421 indicates? This indicates that the code is weighted code. So 8421 code is a weighted code where in each bit is having its own positional weight. So the 0th bit is having a positional weight of 0, first bit is having a positional weight of 1, second bit positional weight 2 and third bit positional weight 3. Like that, each bit is having its own positional weight. So such type of code is called as 8421 code, and this code is also called as natural BCD or binary coded decimal code. So this is about 8421. Now coming to the 2421 code. So 2421 code is also a binary code that has all positive weights. So is positive weighted code. So it is a positive weighted code. It is an unnatural BCD code. So that means a 2421 code is also a weighted code wherein we can represent the numbers from 0 to 9 by using this positional weights 2421 code. Okay. Now coming to the 8421. So 8421, just now we have seen 8421 code is a code in which the positional weights are 8421 and it is positively weighted code. This code is also called as natural BCD. Now 2421, this is also done. Now coming to the state idempotent law of Boolean algebra. What do you mean by idempotent law? So idempotent law states that A into A is equals to A. That means that A is idempotent under the AND operator. So A is idempotent under the AND operator. So as example, 0 is idempotent under the addition of 0 and 1, or independent for multiplication. So 0 is idempotent under the addition of 0 and 1, are idempotent for multiplication. With Boolean algebra, early element is idempotent under both the binary operations and in the Boolean algebra. So that is idempotent law says that the example says that A is 0. So or else we can also say that A dot A is equals to A, and similarly A plus A is also equals to A. So this is the idempotent law. Now state distributive law. So you all know the distributive law. You might have come across this in the mathematics. So idempotent law permits the multiplying of factoring out of an expression. So A into B plus C is equals to AB plus AC. Or according to the distributive law, so A into B plus C, A plus into BC is equals to A plus B into A plus C. So this is about distributive law. So that means we are having AND operator as well as OR operator, but we can interchange the AND and OR operator using this distributive law. Now commutative law. So commutative law says that the order in which the two variables are ANDed or ORed together makes no difference. So even I can connect them. B plus A is equals to A plus B also. So here in this case, A plus B is equals to B plus A. So but I am telling you that there is identity. That means here no two variables are said to be identical, and hence we can just simply rearrange the variables such that A plus B is equals to A plus B. So it doesn't make any change. So this is our commutative law. Now coming to the next one, state the identity law of Boolean algebra. What do you mean by identity law? So the law permits identity law permits multiplying or factoring out of an expression A into B plus C is equals to AB plus AC. So this is our identity law with respect to AND operator, and this is with respect to OR operator. So these are the basic definitions that we have seen that we have come across in the Boolean algebra. I hope it is clear to you all. That's all for this lecture, and these are all the definitions and terminology that we need to remember regarding the number system. That's all for today. That's all for this lecture. Thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.